So number 1A, the electromagnetic inductions occur in two different ways.
Slowly.
The transformer effect by changing the direction of current of the circuit. By changing the direction of current of the circuit. That means it's AC current. That's why we got electromagnetic induction there. Remember the primary coil, secondary coil last week? And then B, the generator effect by relative movement between the conductor and the permanent magnetic field. B, the generator effect by relative movement between the conductor and the permanent magnetic field. Okay. Next, the induced EMF, number 2 now. The induced EMF can be increased by. How can we increase the induced EMF? Number 1. Induced EMF can be increased by number 1, increasing the speed. Increasing the speed of relative motion. Increasing the speed of relative motion. Number 2, using stronger permanent magnet. Using stronger permanent magnet. Using stronger permanent magnet. Number 3, induced EMF can be increased by number 1, increasing the speed of relative motion. Number 2, using stronger permanent magnet. Number 3, changes of flux. Changes of flux occur at the right angle. Changes of flux occur at the right angle. So 3, who didn't get it? How can we increase the induced EMF? Number 1, using stronger permanent magnet. Number 2, increasing the speed of relative motion. Number 3, changes of flux occur at the right angle. Siapa tak dapat? Anyone? All got it? Okay, list the differences between left-hand Fleming rules and right-hand Fleming rules. Okay, left-hand Fleming rules and right-hand Fleming rules. How to show the differences between left-hand and right-hand? Okay, let's start. Okay, left-hand Fleming rules and right-hand Fleming rules. Okay. If I want to see the differences between left-hand and right-hand Fleming rules, okay, what should I do? Okay, first, left-hand Fleming rules. Number 2 is right-hand Fleming rules. Okay, left-hand Fleming rules, we are using electrical energy and changing it to mechanical energy. Mechanical energy. All right. So left-hand Fleming rules, electrical energy changed to mechanical energy. Okay. What happened here is that the interaction between permanent magnetic field, permanent magnetic field, permanent magnetic field and electromagnetic field. The interaction between permanent magnetic field and electromagnetic field produce what? Produce resultant force. Produce a resultant force. This is left-hand Fleming's rules. Right-hand Fleming's rules, mechanical energy Okay. Mechanical energy. We change to electrical energy, where there is a production of what current? Induced current. So induced current is produced. Okay. Right hand Fleming's rules, production of induced current. We produce induced current. Okay. And then right hand Fleming's rules, what happened? First, we must create the changes of flux or electromagnetic induction. Changes of flux. Changes of flux produce what? Induced current. Induced current. Any question, guys? Siapa ada soalan? Hello? Kalau? Any question? Kritisha, any question? No question. Okay, next one. See, left hand and right hand Fleming. Okay. The next one to understand here, when we use left hand Fleming rules, it is actually only used for motor. Left hand Fleming rules we use for motor, guys. This is used for motor. Motor. It can be AC or DC motor, but all the motors using left hand rules, right? And then right hand Fleming's rules we use for generator. Right? Any form of generator. There are two types of generator because this is production of induced current. This is to produce induced current, right? So if you are going to produce induced current, right? To produce induced current, right? So it is for generator. Generator. The generator can be AC or can be DC. All right. Any question, guys? So left hand and right hand. This is the difference by using left hand and right hand. Any question? Anyone? Any question? No. Okay. Ada soalan tak anyone? Alim ada soalan? Anyone? Tam Jiashan, any question? Tam Jiashan, any question? Alim, where are you, Alim? Alim, ada soalan tak? Ada soalan?
Ya, ada.
Thank you. Selamat berpuasa.
Thank you, Sir.
Alright, okay, next. Okay, next kita balik ke tadi ya. Okay. Okay, dah. Sekarang, list a few differences between a DC motor and AC motor. This one later lah. Okay, now this one you can read up on your own. Okay. List the differences between a step-up transformer and a step-down transformer. Okay, what is the differences between step-up transformer and step-down transformer? Okay, what will be the differences between step-up and step-down transformer? Okay, let's look at step-up and step-down transformer. Okay, what is the differences between them? Okay, step-up and step-down transformer. Okay. Okay, when we use step-up transformer and step-down transformer, okay, step-up. Step-up transformer and step-down transformer. Step-up transformer, the primary voltage will be smaller, the secondary voltage will be bigger. Step-up. Step-up, primary voltage smaller, secondary voltage bigger. Step-up, number of turns of wire in secondary is more than the number of turns of wire in primary. Step-up, Number of turns of wire in secondary is bigger, primary is smaller. Primary is smaller, primary is smaller. Okay. Then the current in the secondary is actually smaller. The current in the primary is actually bigger. This is step up. Okay. Step down. Step down. Primary voltage will be bigger. Secondary voltage will be smaller. Number of turns in primary will be bigger. Number of turns in secondary will be smaller. And if you look at the current value, okay, in primary will be smaller, but secondary is bigger. So this is how the step up and step down system works, okay? So if you have a step up transformer, secondary voltage bigger, number of turn in secondary coil bigger, but the electric current, the secondary output current is smaller. Step down transformer, voltage of secondary is smaller. Number of turn of secondary also smaller. So step down, decreasing. But the secondary current is still big, all right? Output current is still big, all right? This is the differences between step up and step down transformer. Step up and step down transformer. Alfred, do you have any question?
No questions.
Thank you. Sean Wong, do you have any question?
It's cool. It's cool.
Okay, thank you. Okay, let's move on now. We go back to this one. Okay, now the slip rings and the commutators. It's not very easy. Okay. The slip rings are used in, where do we use the slip ring? Slip rings are used in AC motor and AC generator. Slip rings are used in AC motor and AC generator. The slip rings are used in AC motor and AC generator. Okay. Then where do we use the commutator? The commutator is used in DC motor and DC generator. I repeat again, slip rings, number 6, slip rings. Slip rings are used in AC motor, AC generator. Slip rings are used in AC motor and AC generator, slip rings. Commutator are used in DC motor, DC generator. Any question, guys?
Jashan asks how to differentiate motor and generator. Oh, sorry, Jashan. I love you.
Oh, motor using electric current, and change the electrical energy to mechanical energy. Motors. Your fan motor, your blender motor, your whatever motor we are using, they use electric current and they change it to rotation. That means they are changing electrical energy to mechanical energy. That's motors. Generator is like the hydroelectric power station there. We have a big, huge turbine. As the turbine rotate only, we produce electric current, induced current. So generator is using mechanical energy and producing electrical energy. Any question? Boleh? Understand or not?
So the one pasar malam, that one is generator.
Generator. They put diesel or petrol, all that are generators. Your farm got generator, Marcus?
God.
Your farm there got
God.
generator or not? Got.
God,
All that are
God.
generators. All that are generators. Okay, next. Now we have to look at the advantages of the national grid network, kan? Okay, ini semua saya belum ajar. Okay, ini lenses lo saya belum ajar. Transformer. Okay, number 17. Diagram 12.1 shows two transformers, P and Q. Okay. I will explain this now. Later you all do. Okay, now. Diagram 12.1 shows two transformers P and Q. Okay. Transformer P, if you see here, primary voltage 240 volt. Number of turn in primary coil 2000. Number of turn in secondary coil is 500. So this is a step down transformer. Transformer P is a step down. Transformer Q, number of turn in primary is 500. Number of turn in secondary is 1000. Okay. So for transformer Q, this is a step up transformer. Transformer Q is a step up transformer. Transformer P is a step down. Okay. The first question, what is meant by a transformer? Okay, let's answer. A transformer is an electrical device. A transformer is an electrical device which can increase or decrease the output voltage. So transformer is an electrical device which can increase or decrease, the output voltage. So transformer can increase or decrease the output voltage. That's what transformer can do. Increase or decrease the output voltage. That's what transformer can do. Increase or decrease the output voltage. Okay, done. Transformer. An electrical device which can increase or decrease the output voltage. Okay, done. Based on diagram 12.1, which transformer is a step-up transformer? Which one is a step-up transformer? Transformer Q. Give one reason for your choice. What is the choice? What is the reason? Number of turns of wire. Number of turns of wire in secondary coil. Number of turns of wire in secondary coil is bigger than the primary coil. So number of turns of wire in the secondary coil is more than primary coil. Number of turns of wire in the secondary coil is more than primary coil. Okay, that's why it's a step-up transformer. Calculate the output voltage of P and Q. Use the formula, guys. Vs over Ns equals to Vp over Np, or terbalikan, any formula you can use. Okay, we calculate already. Then energy is lost. Energy loss, I think I haven't explained yet.
Wait, Dave.
Not enough markers. Okay, now, okay, this is the question I gave you all for weekend. See how many of you tried? Okay. The following circuits use transformers which has 100% efficiency. Okay, what do we mean by 100% efficiency? That means there's no loss of energy. There is no loss of energy. When we say 100% efficiency, there is no loss of energy. Okay, so when we say 100% efficiency, remember, guys, input power must be equal to output power. Input power must be equal to output power. That's 100% efficiency. Okay, now. Okay, let's start with the first one. For each case, determine the unknown quantity. So first one here, we have the first one, we have number of turn. Okay, primary voltage over number of turn in primary equals to secondary voltage over number of turn in secondary. Okay. So we see here primary voltage 5 volt, number of turn is 20. Secondary voltage, we do not know output voltage, secondary voltage, number of turn is 60. So the secondary voltage automatically will be 15 volt. Siapa tak faham? This is output. This is the output. Output voltage. Siapa tak faham? Who don't understand? All okay? Are you all okay?
Yes.
Yes.
Very good. Very good. Okay. Done with A. Now we go for B. Okay, now we go for B. Okay, B here now. Okay, now we have 400 turns. Okay, so again, primary voltage over number of turn in primary equals to secondary voltage over number of turn in secondary. Primary voltage 240 volt. Number of turn in primary is 400 turns. Okay. Secondary voltage is 12 volt. 12 volt. So what is the number of turn in secondary? Cepat, kira semua orang kira cepat berapa? How many we get, guys?
20.
Kira lo.
20.
How many?
20.
20. Semua dapat 20 ya? All got or not? Who don't understand? Put up your hand. Of course, I can't see you lah. Okay, B okay, Leila, okay tak? B okay tak, Leila?
Okay.
Alright, thank you, Leila. Selamat berpuasa, Leila. Marcus, ada
Thank you,
puasa tak,
sir.
Marcus? Welcome. Marcus, ada puasa tak? Hey, Marcus, don't want to answer
Huh?
also. Ada puasa meh? Tak ada lah,
Oh.
tak ada. Okay.
Ah.
Understand.
有点尴尬啦。
Okay. Primary voltage over number of turn of primary equals to secondary voltage over number of turn of secondary. Primary voltage we do not know, it's called input. Number of turn is 1000. Secondary voltage, okay, is 10 volt. Number of turn is 250. So what is the primary voltage, guys? Input voltage berapa?
40.
40 volt. Very good. Whose voice is that? Whose voice is that?
Yisheng.
Oh, very good. Okay. Done with this. Okay. Yeah. Okay, next we move on. Okay, next one. D. Okay, we are looking for now the number of turns. Again, same formula. Primary voltage over number of turn of primary equals to secondary voltage over number of turn of secondary. Okay. Primary voltage 12. Number of turn of primary tau. Secondary voltage is 36 volt. Number of turn is 2400. What is the number of turn in primary? Berapa? Kita panggil.
800. Oh, sorry.
Okay, answer lah, answer. You know already what? Answer. 800 turns ah.
Yeah.
Correct ah, Nigel? Alright, thank you. Nigel? Correct or not? Hi, Nigel. Nigel, correct or not? Hello, Nigel.
Sorry, type in chat.
Yes, Jordan, okay, Jordan.
Okay.
All right, thank you. Okay, next question. See here. Diagram 1 shows a multi-tap transformer. Okay. The primary coil has 2,000 turns. The number of turns in section PQ, QR, RS of the secondary coil are 20, 30, 50. If a 120 volt power supply, this is 120, betul kan? Typing error. 120 volt power supply is connected to the primary coil. Determine the output voltage at each section. Okay, so QS. So A, primary over number of turn, equals to secondary over number of turns. Okay, so primary is 120 volt. Number of turn in primary fixed 2,000. Secondary now is QS. Q to S. Q to S. We do not know the voltage, but we know number of turn from Q to S is 80. 80 turns. So what is the voltage of QS?
4.8.
How many? Yicheng, what's the answer?
4.8.
Thank
4.8.
you. Thank you. Say pat. Betul lah? Betul ke?
Say part for yes,
dot,
yes.
Say dot pat. Okay. Say dot pat lah. Oi.
Say part
Okay.
for
Now
yes.
we do B. Now we do B. Okay. A, who got problem? Who got a problem with A? Anyone? No issue, guys? Okay, let's continue with B. Let's continue with B. Okay, now we go for B now. Okay, B. Now let's see. Primary voltage now B. Primary voltage over number of turn of primary equals to secondary voltage over number of turn of secondary. Primary voltage 120 volts. Number of turn 2,000. Okay. Secondary voltage PQ. We do not know. But we know the number of turn for PQ is 20 turns. Number of turns for PQ is 20 turns. Therefore, voltage of PQ will be 120 volt over 2,000 times 20. All right. So what we get here? What's the answer? Sandra, what's the answer?
1.2.
1 point. Okay, very good. Thank you. And the last one, PR. Okay, who got issue here? Anyone got issue here? This calculation? No means okay. Let's call. Okay, 2B all okay, guys? Okay, now 2C. 2C. Okay, let's call 2C. 2C. Okay, now number C now. Primary over number of turn. Secondary over number of turn. Primary is 120. Number of turn 2,000. Secondary, we do not know, but it's between P and R. Number of turn between P and R is 50. So the voltage of PR. Adeline, what's the answer? PR voltage.
3.
Thank you. Okay, guys, done. Who got question? Any question? Siapa ada soalan? Anyone? Any question? If no, we go to the next question. This one supposed to do at weekend. Semua ada cuba. Ha? Sean, you finish already, right? Sean Kern and Sean Wong.
Yes.
Very good. Okay, sudah habis bahagian ini. Okay, we go to the next one. Is this one? Okay. Okay, let's see this number 3. A lamp label 12 volt, 24 volt, 12 watts. 24 volt and 12 watts. Okay, it's connected to a step down transformer as shown in the diagram. Okay, in diagram 2. The lamp lights up at normal brightness, assuming that the transformer is 100% efficient. What is 100% efficient? Whatever input power here and whatever output power here, we assume both are equal. When the input power is equal to the output power, we say 100% efficient. 100% efficient. Okay, now next one. Calculate the number of turns in the secondary and current in the primary. Okay, let's see. All of you try now. All of you are given 2 minutes to try. First try. Semua orang cuba 2 minit. Cuba dulu, write down on your notebook. Must have your notebook by now. Are you all doing? Okay. Kalau, give me answer.
500.
500, huh?
Yeah.
500 turns. Okay, very good. Now, number 3B. Number 3B. Let's call... who to call, huh? Let's call Yongsin. Assuming the transformer is 100% efficient, calculate the current flowing in the primary coil. Okay, when we say 100% efficient, input power is equal to output power. Input power is VI of primary and primary because this is input. Output power is also VI, but this is secondary and secondary. All right, secondary and secondary. Okay, now, if I follow here, the primary voltage 240 volt. The primary current, I do not know. Primary coil, primary current, you don't know. I don't have to do this because the output power is given 12 watts. It's given 12 watts. Output power is given 12 watts. So the output power is given 12 watts. What is the current value? Berapa kelas? Siapa order jawapan?
0.005.
0.05. 0.05, 0.05.
0.
20 man.
0.05. 10.
0.
20
lah.
mana ni?
10.
Ayah, saya pergi bagi
Ayah,
maths lah.
I'm good
I
at
go
maths.
tell your
I'm
maths.
bad at maths, sorry.
I'm going to tell your maths teacher. Okay, number 3 done. Who got issue with number 3?
Hooking.
Anyone? Okay, cantik.
What the
Okay, very, very good. Okay, this one done. Okay, now we go for number 4. Okay, number 4, Okay, number 4 now. Okay. Diagram 3 shows. Okay, diagram 3 shows a transformer with 100% efficiency. Again, 100% efficiency. That means whatever input power is equal to output power. Okay. Primary coil P and secondary coil S. Okay. The secondary coil is connected to resistor R. Okay. Output. The ratio of number of turn is 1 to 5. So S is 5 times more than P. So you can take your own value. I will take easy one, 100 and 500. Finish it. Simple as that. If I take this 100, this is 500. So it's a ratio what? 1 to 5. Okay, now if a 2 volt AC, source is connected to P, what is the potential difference across R? Okay, semua orang kira. Number 2, if the current flowing in P, right, is 5 ampere, what is the current flowing in R? Semua orang kira. And finally, determine the resistance of resistor R. Okay, semua orang cuba. I'm going to ask anyone also to answer now, Mr. All of you try. Semua orang cuba. Okay, number 4A. We call, who to call? Darshana. Do you know answer for number 4A or not? What's the answer for number 4A?
I'm trying a teacher. Wait, huh?
Okay, try.
Teacher, I know for the primary voltage is 2 and then the number of coil we need to take 100.
You can take 1 to 5. I can take 1 to 5 is like 100 and 500 I can take.
Okay.
Up to you.
My voltage is for secondary is 10.
Very good. Secondary voltage is 10 volt. Correct.
Correct.
Yes, correct.
Okay, thank you, teacher.
Welcome. Who don't know this? Who don't know this? Check Chuan, you know or not? This one, 10 volts. Check Chuan. Check Chuan. You see here, primary voltage 2 volt, number of turn we don't know. We can take 1 or 100, it's up to us. Secondary voltage we do not know. The ratio is 5. Here 1, here 5. So secondary voltage is automatically 10 volts. Want to take the ratio 100 to 500 also can. Then input power and output power is equal for B. For B, input power and output power is equal. So primary voltage is 2. Primary current is 5 ampere. Secondary voltage, we know the 10 volt. 10 volt. So what is the secondary current? What we get? Jaden?
1.
1 ampere. Thank you. And the last one, determine the resistance of R. You know the voltage is 10. You know the current is 1. What should be the resistance? The resistance should be 10 ohm resistance. That's all. Done. Okay, perfect. Sangat cantik. Sudah habis bahagian ini. Anyone got question or not here? Siapa ada soalan? Anyone? Hello? Semua okay? Okay, done. Okay, now we were doing this just now. Right. Okay. Now this one we can leave it first. We go back to the group. Okay, all of you. Apa khabar semua? 43. Who's missing from your class? Who's missing Jaden, from your group?
Probably Terrence.
Terence lah, yalah. Others all okay. Oh, yo, thank you. Graham Bell, 19 over 19. Very good. Thank you. Thank you. Okay, let me explain to you all. Okay. Listen, okay, now. The other day when I teach you all transformer, the next page got a table that shows how we lose energy in a transformer. Then down there we got 3 types of transformer. We got multi-tap, we got auto and variable. We got multi-tap transformer, we got auto transformer, and we got variable transformer. Okay. What is multi-tap? Multi-tap transformer, all right? Look at multi-tap transformer. It's like a system where there's the input here and the output is here. It's a transformer. But the knob is there. The knob will decide which voltage do you want. You want 9 volt, or do you want 12 volt, or do you want 24 volt? So you just turn the knob and you decide which voltage you require. See, it's very simple. What happened here is that you'll have a knob and you just turn the knob, which voltage you want, 9 or 12 or 24. And multi-tap normally are step-down transformer. Normally a step-down transformer because input is normally 240 volt. Okay, this is multi-tap. So multi-tap, you can have 1 or 2 or 3 or 4 choice of output. Output, you have a choice. You can decide how many you want, multi-tap. Auto transformer is like your handphone charger. You see your 3-pin plug, all All right, you plug in and you charge your handphone. Your 3-pin plug is actually taking in 240 volt, but it is supplying only 5 volt to your handphone. So this is auto transformer. Auto, it's automatic. You don't do anything, you just plug in and play, that's all right? Even a lot of TVs also, they're only taking very less voltage, maybe 120 or less, the LED TVs are, okay? So handphone charger is the best thing to explain. Handphone charger doing 2 works, Number 1, it is changing AC to DC. Number 2, it's an automatic step-down transformer. Automatic step-down transformer. How many transformers are there? Multi-tap, auto, and variable. What is multi-tap? There'll be a few output. You choose the output. Do you want output to be what? You choose the output. So multi-tap input is only one. Always input is only one. All right. But you choose which is the voltage output you need. But only got 2 or 3 or 4 value maximum. That's all. Auto transformer, you don't do anything. Input and output are fixed. It's auto. That's why it's called auto transformer. Variable transformer, it's like the rheostat system. You will rotate the knob. The input is 1, maybe 240 if you plug into the Malaysian system, everywhere 240. The output we can control. What output we want? We can control the output. It's a variable. We can control and control and control. All right? Okay. It's 2 o'clock already. I got your message already. All right? It's 2 o'clock. I got your message already. Okay, no issue. So got 3 types of transformer: multi-tap, auto, and variable. Multi-tap, auto, and variable. So normally we use in school multi-tap and auto. All right. Variable is like a rheostat system, like a dimmer, the room light dimmer. You can increase the voltage or decrease the voltage of output. So all this can be done. Okay, for today's lesson.